Hello everyone, and welcome back to Ask-a-Naturalist with the Schuylkill Center for Environmental Education. I am Rebecca, your host naturalist for this evening, and today we are going to talk the summer solstice and the sun. Now, the summer solstice happened last weekend. It was Saturday the 20th, and it was a really big, exciting day. And we are going to talk all about what the solstice means, both for nature and historically for people and animals, and it's going to be a really cool discussion. So a little bit about Ask a Naturalist before we get started. Wait till a couple more people come on if they're going to. Ask a Naturalist is weekly. It is Mondays at 5 to 5:30 on Facebook Live. I am here every week with new topics to talk about and answer your questions about, or learn new things from you as well. So if during this segment you have any questions about anything I'm talking about, or if you have any comments that you would like to make, if you know some things about the sun or the summer solstice, please comment below. I am reading comments as we go through this, so it's live, which is very cool. And also, if you have ideas for future weekly topics, please comment below as well. I love getting ideas. I want to talk about what you want to learn about, so that is how I get my topics. And feel free to comment below, or when we introduce the topics on our Facebook page for the following week, feel free to comment under those as well with any questions that you might have. So let us get started, shall we? Let's start with what the summer solstice is. Like I said, the summer solstice took place last weekend. It was the longest day of the year for us in the northern hemisphere. And what that means is that, so the earth, as we know, is on a tilted axis, right? And so as it goes across in its orbit around the sun, the orientation of the axis in relation to the sun changes. And so for one day a year, we have our axis and our North Pole tilting as close to the sun, the shortest distance of the whole year. And on the opposite side of the world then, the South Pole is tilting as far as it possibly can from the sun in that year. So it is the Northern Hemisphere's very longest day of the year, the brightest day of the year, and then on the south side it is the shortest day and the darkest day of the year. And then when we circle back the other way for the winter solstice, then for us on the northern hemisphere it is our shortest day, our longest night, our darkest day, and that is in December, toward the end of December, usually around the 20th or the 21st, and it'll be the southern hemisphere's longest day of the year. So now we know how that works, and it is really interesting actually. So let's say that the Earth's tilt drives the seasons, right? And so the seasons depend on the relative temperature of the different hemispheres to Earth, right? The summer solstice and the winter solstice both take place worldwide at the exact same time for the whole world. However, based on local different time zones, those times of when you can experience it will differ, the exact solstice. And so the other thing about that is that in between the solstices, we also have the equinox. Now, the equinox is when the axis is actually an almost nearly equal distance at both of the north and the south points of the axis. And so that happens in the springtime and the fall, and that is when daylight and nighttime are almost completely equal in terms of their length of the day around the whole world. So those are the equinoxes, those are the solstices, and many other planets in our solar system do have solstices and equinoxes because a lot of them are also on tilts in their axis, so they will experience longer and shorter days and seasons. However, their seasons and their temperatures vary greatly from Earth actually. And that is because either their tilt is different or because not all of their paths around the sun are very, not all paths around the sun are equal. The Earth's is relatively circular compared to some of the other parts that could be, and of the other planets. And so what we come across will be obviously very different temperatures, very hot, very cold. If the path around the sun is more ovular, perhaps, maybe, that will be very different as well. So we will start to talk a little bit more about a question that I get quite frequently and that I saw quite frequently too, is why don't the longest and shortest days of the year also reflect the hottest and coldest temperatures of the year as well? And that's a really good question actually, and the reason for that really is that it takes time for the Earth's land and water to cool and to heat. It doesn't happen just overnight just because the sun is closest or furthest. So we start to see those effects of being closest and further from the sun about a month later. So with variation, of course, especially in present times, in present day, we will start to see the hottest temperatures of the year in our hemisphere recorded in around July and August. And that is about a give or take, again, with variation, with other outlying factors affecting the warming of our planet right now. But that is give or take a month after the summer solstice. So it takes about that long for us to catch up in temperature to our distance from the sun, which is interesting because even after that, we are in fact further from the sun than we were during the solstice. So it does take a little while to catch up to that. And then of course during the winter solstice, we see our recorded coldest temperatures usually in January, February. Those are, with variation, obviously our coldest temperatures, and that's about a full month after that winter solstice. So it is very interesting, and there are a lot of effects on nature from the solstices and from the change in daylight, both elongating and then growing shorter, that occurs throughout the world. And possibly the creatures that are most affected by these solstices and by these changing lights are the creatures that exist on the North and South Pole, who will experience full 24-hour daylight and full 24-hour darkness. So those creatures have learned to adapt really well, actually, to that variation in sunlight. Now humans, we have a circadian rhythm. We are very much dependent on the sun and lack of sun in order to know when it's time for us to sleep and time for us to be awake. And so humans, studies have shown, are actually really bad at determining when is a good time for them to go to sleep in times of mostly daylight or mostly nighttime. Without that variation, we actually forget our sleep cycles in a way that will ultimately start to damage our body. We will become sleep deprived. But not all creatures are created equal. And there are a bunch of creatures actually whose sleep cycles and active cycles are completely different maybe than, and completely independent of the sun and the lack of sun. So one example of that actually is reindeer in the Arctic Circle. Reindeer actually are on an ultradian rhythm, which is different than our circadian rhythm, and it means that under this rhythm, they only sleep when they need to digest food. And so what that means is they actually will take mostly naps throughout the day as their sleep cycle allows and requires them. They don't usually go into that deep REM cycle that we humans find ourselves needing to go into. So they are completely unperturbed by the sun, whether it's that 24-hour sun cycle or 24-hour darkness cycle. They are completely independent of that. There are other creatures such as sandpipers that are in the Arctic Circle who exist as partners and help guard each other's eggs, and they will only sleep when their partner decides that they are ready to be active to guard their eggs to go get food. They will take turns sleeping and being awake on that schedule. So that's a schedule that is completely, again, independent of the sun. They're not affected by the sun at all, unlike us, where it might be hard to fall asleep in full daylight unless you're really super tired. We tend to need darker, cool environments in our bedrooms to help us fall asleep. But interestingly enough, in the Arctic circles, there's really no advantage or need to be awake, active, or asleep, inactive during certain parts of the day. So in Pennsylvania, when you get closer to the equator, really anywhere in the US, obviously part of the big reason between whether or not animals are nocturnal or diurnal, meaning they're active during the day, nocturnal is active at night, is because of competition and because of protection and defense against predators. So animals that are nocturnal, awake at night, they are either doing that so that they can have less competition from other animals that might eat their same prey during the daytime, or they're trying to protect and defend themselves from predators that might only be awake during the daytime. So for instance, an owl is active at night because it hunts mice, it might hunt small birds, other things, and there are a lot of other birds that would hunt those same things during the day. So over time, the owl has evolved to be nocturnal and have certain adaptations that allow it to be active at nighttime. And in this way, it eliminates a lot of competition and gets a lot of time to try and get its prey without any disturbance. And then contrastingly, a lot of mice are nocturnal because there are a lot of animals that would like to eat them during the daytime, and they have a lot more success foraging, scurrying around for their food and for their babies and their homes during the nighttime, even though they still have that owl to contend with. That's a lot fewer predators than are trying to eat them during the day. Now, Kyle asked, how were we able to record the solstices before modern technology? That is a really, really good question, and it's a question that I am not going to pretend to be an expert of course, but I do have a few points that I could make to speak to that, and then the rest I am still definitely learning as well. So feel free to comment if you have anything else to add to this question, because it's a really good one. So one of the ways that we know, at least, that people were able to record solstices, record differences in the sun and seasons, is from ancient structures around the world, actually. And so, for instance, one of them is Stonehenge. Stonehenge is, we might all know, it is a structure of great mystery and intrigue that exists in England right now, and it is a stone circle, and every year they actually have a summer solstice celebration that attracts thousands of people around the world. It's thought to have been going on, this celebration around Stonehenge, for thousands of years, and the reason it attracts people is that when the sun sets, when it rises and sets, I believe, rises, when the sun rises, it will come through right through the two entrance stones and right over the heel stone, which is the entrance to this stone circle. The sun comes right through the center of it, and its sun's rays shine all throughout the circle. So we know that people were measuring, calculating, and then wanting to understand and wanting to be able to always calculate the different positions of the sun. There are a lot of other ways that we know that people were measuring sunlight in ancient times every day. They used it for crops. They used it because a lot of ancient cultures did worship the sun all around the world. So I like I said, will not pretend to be an expert on the technology that was used. However, it is known by scientists that there were mathematicians and there were scientists and physicians in ancient times who spent their lives studying the sun, the stars, the moon, the constellations, all of that in various ways and with various technological development. And it really drove entire cultures in that way. The sun did, and the stars did, in fact. So that itself is a fascinating conversation that could go on and on, really. So let's talk a little bit about the sun itself, because the sun is the center of all life on Earth. It keeps us warm, it feeds our plants, it is everything. The sun is everything, truly. Now, the sun is the center of our solar system. It is a yellow dwarf star. And in our solar system, its mass is actually such that it makes up 99.8% of the total mass of our solar system. So when you think about it, our solar system, which to us is everything, is really mostly just the sun, and the solar system itself is quite small. Now, like I said, it's a yellow dwarf star, and it is about 93 million miles from the Earth. And the surface, so the core of the sun, the center core, is about 27 million degrees Fahrenheit. That's a little hot. It's a little too hot for me, personally, just an opinion. But the good news is that as you leave the core and you enter the surface of the sun, which is the part of the sun that we see, although please don't look at it directly with your eyes, what we actually will see is the sun cooling down to a nice, tolerable, merely 10,000 degrees Fahrenheit. And that's fine with me. Maybe still a little too hot, but only just a little bit, right? So that is the sun. And the sun is composed of many parts, and it is a big piece of gas. And its gravity has brought all of the planets together in their exact orbits. And so, sorry, I lost my notes on my page. So the sun is huge, the sun is hot, and the sun is the source of all life. It controls our tides in its way, it controls our life, it controls our seasons and weather, and everything else that you can think of. And people around the world, historically and today, kind of like what I was saying before, they have always given reverence and sometimes worship to the sun. And today around the world you can see many, many ancient structures actually were meant to incorporate or even follow and revere the sun. From Stonehenge to the pyramids to structures and temples in ancient Mayan and Aztec cultures. So anywhere in the world that you go, really, you will see both modern and historical reverence for the sun. And in the Arctic areas where there are 24 hours of sunlight during the solstice, you will see giant celebrations that take place over entire 24-hour periods of time where there is dancing and food and festivals and all kinds of things going on. And again, part of that is because we are, as humans, forgetting our sleep schedules as well. So with no sleep schedule and without our nighttime, daytime circadian rhythm to keep us fully in line, we will party and celebrate the sun all night long for 24 hours. So that is a brief, fun introduction to the summer solstice and to the sun itself. And if you have any questions or comments, anything, if you're watching this later and you know something about the solstice that I didn't mention, please, please, please put it in the comment section, because like I said at the beginning, I love to learn too. And I'm really looking forward to learning with all of you and learning together. If you have any questions or comments about any other videos, same thing, leave them in the comments, suggest things for future topics. Thank you for coming to Ask a Naturalist as always, and I'll see you next week. And please check out our Facebook page, website, Instagram, etc. for other events and programs we have going on all throughout the summer. We have a lot of virtual programs going on right now, and it's great. So please come again, and I will see you next week, and have a fabulous, naturific evening. Thank you!